Farming is entering a new era where machines don't just work, they think. And when you see how modern farms operate today, you realize this isn't science fiction anymore. It's happening right now in real fields with real farmers. In this video, we're going to break down the newest modern farm machines being used today, explain how they actually work in simple terms, and then look at the future technologies that could make agriculture dramatically easier, faster, and more precise. Let's begin with the foundation of modern fieldwork: GPS-guided tractors and auto-steer systems. Imagine driving a giant machine across hundreds of acres. One small overlap wastes fuel, time, and inputs. Auto-steer fixes that. With satellite guidance, the tractor follows perfectly straight lines, reduces overlap, and keeps every pass consistent. And when RTK level correction is added, accuracy becomes incredibly tight, down to centimeters, so farmers can plant, spray, and harvest with repeatable precision season after season. This precision becomes even more powerful the moment a smart planter enters the picture, because planting is no longer a rough estimate, it's controlled manufacturing on wheels. A modern planter carefully manages seed spacing, placement depth, and seed-to-soil contact so crops emerge evenly. And that matters because uniform emergence creates stronger stands, stronger roots, and stronger yields. Many planters also use intelligent systems that keep depth consistent even when the ground changes, so hills, bumps, and soil variability don't ruin the seed placement. Now add variable rate technology, and planting becomes even smarter, because a field is not one uniform surface. Some zones have stronger soil, better moisture, or different organic matter. Variable rate seeding changes the population as the planter moves, placing more seeds where the field can support them and fewer where it can't. That means farmers spend smarter, reduce waste, and get more consistent results across the entire field, not just in the best spots. Next comes variable rate fertilization, another huge shift from the old one-size-fits-all approach. Instead of spreading the same amount everywhere, modern systems apply nutrients exactly where they're needed, when they're needed. This protects yield, saves money, and also reduces environmental loss, because over-application can increase runoff and inefficiency. To do this well, farms rely on data, especially yield maps and field performance maps. During harvest, modern combines don't just cut and collect, they measure grain flow and moisture continuously, second by second, while moving through the field. That information becomes a yield map, revealing which zones performed best and which zones struggled. And more importantly, it helps farmers ask the right questions. Was it soil, water, nutrients, drainage, or timing? That map becomes the blueprint for smarter decisions next season. Now we move to the sky, because drones have become one of the fastest tools for field intelligence. Walking a large field takes time, and time is expensive in farming. A drone can scan huge areas in minutes and reveal patterns that you simply can't see from the ground. Early crop stress, nutrient deficiencies, irrigation problems, weed pressure, storm damage, and drainage issues often show up as subtle patterns from above. That means farmers can scout faster and fix problems earlier before a small issue becomes a big yield loss. And drones are not just about pretty aerial footage. Many farms use them to build detailed field maps that guide scouting. Instead of guessing where the problem is, a farmer can go directly to the exact zone that looks stressed, check what's happening, and respond with the right solution. Behind the scenes, there's another group of machines doing quiet work all day: field sensors and on-farm weather stations. These tools collect real measurements: wind speed, rainfall, temperature, humidity, and soil moisture, so farming decisions become data-driven. This matters especially for spraying and irrigation. Spraying at the wrong time can cause drift, poor coverage, or wasted product. Irrigating at the wrong time can waste water and weaken root development. Sensors help farms choose the best window, so actions happen based on reality, not guesswork. Water management is becoming smarter too, and this is one of the most important shifts in modern agriculture, because water is often the most valuable input on the farm. Automated irrigation systems can respond to real measurements. Center pivots can be monitored and adjusted remotely. Drip irrigation delivers water directly to the root zone with minimal waste.
Smart valves open and close as needed, which saves labor and protects crops during critical growth stages. Instead of watering on a schedule, the farm can water based on actual soil conditions. Then we have modern sprayers, and the change here is massive. For decades, spraying was often blanket coverage, treating everything the same. Now it's becoming precision targeting. Section control prevents double spraying by automatically shutting off boom sections where the machine has already passed. Camera-based systems are taking it further by identifying weeds in real time, so only the problem spots get treated. That can dramatically reduce chemical use while still protecting yield. But all this precision depends on one critical thing: calibration. Clean nozzles, accurate rates, correct speed, and safe conditions determine whether spraying is truly effective. The difference between precision and problems is often one small setup detail. And with modern lighting and automation, farms can work longer windows, even into the night when conditions are better and schedules are tight. After that, we step into the robotics era, where machines begin to do tasks that used to require a lot of manual labor. Field robots can scan rows with computer vision, distinguish crops from weeds, and remove weeds mechanically without spraying. Some future prototypes even experiment with ultra-targeted energy methods to control weeds at the source. And instead of one giant machine compacting the soil, the future may use swarms of smaller robots working together, lighter, safer, and more efficient. In orchards and specialty crops, harvesting robots are improving year by year, focusing on gentle handling, consistency, and speed. The goal isn't just to pick fast, it's to pick carefully with less bruising, less damage, and less waste. In greenhouses, automation controls the climate like a living ecosystem: temperature, humidity, airflow, and irrigation working together in a controlled environment. Hydroponics supports this by delivering precise nutrient mixes through water, often recycling the system to reduce waste. Vertical farming pushes the idea even further by stacking production in controlled spaces, producing greens and high-value crops with a smaller land footprint and controlled conditions. After harvest, automation continues. Sorting and packing lines use vision systems to detect defects quickly, and robotic arms pack consistently, reducing damage and labor strain. Cold chain technology keeps food fresh longer, meaning less spoilage, less waste, and better quality by the time it reaches consumers. Livestock farming is evolving too. Robotic milking systems can milk cows on schedule while tracking basic health patterns. Smart collars and sensors detect behavior changes that can signal health issues early. Automated feeding systems deliver consistent rations at consistent times, and barn sensors keep temperature and air quality stable, improving animal comfort and performance. Finally, we look at what's next, and this is where agriculture could become truly easy mode compared to the past. Autonomous tractors are being developed to navigate with sensors that can see obstacles, helping farms operate with fewer workers during labor shortages. Electric farm machines are rising as well, often quieter, simpler, and cheaper to maintain. Hydrogen concepts may power longer work hours for heavy equipment. More farms are generating energy on-site with solar to run machines and systems. Coordinated drone swarms could map fields rapidly. Robotic sprayers may operate only when conditions are safe, reducing drift risk. Irrigation could run like autopilot based on soil needs. And digital twin farm models may simulate decisions before a single dollar is spent, helping farmers plan proactively instead of reacting after problems appear. The big idea is simple. These machines remove guesswork, reduce waste, save time, and help farmers grow more food with fewer resources. But the most powerful part of the system is still the human mind, using smarter tools wisely, making better decisions, and improving season after season. If you want more breakdowns like this, subscribe to Agriculture Verse and tell me in the comments which machine you want us to explain next.